But it is a rule that if you have something in a format similar to this, where you have separate terms being divided by the same denominator, you can write it like this and it still be equal. Okay, so, and here, let me use numbers because maybe that'll make more sense to you. Ordinarily, in a fraction, like set up like this, you have to work out the entire numerator before dividing. So, what is 1 plus 3? And this becomes 4/5, right? If I were to separate it and write it like this, what's 1/5 plus 3/5? You get the same thing, okay? So this is really important because pretty soon we are going to be, well, you might have already on your homework, be rearranging equations into slope-intercept form, and it's really important, like when you have to divide the whole other side by 5, that you're doing it to both terms, or whatever the case. So here's an example of what it looks like. If I have this and I want to rewrite each quotient, so these are all quotients, what operation is quotient? Okay, good. So these are all division problems because they're written in fraction form. We want to rewrite them as a sum or a difference. So here's how that will look. Side note, hopefully you guys know like when a term starts and ends. Terms are like sections of an expression. So terms are separated by operation symbols, like plus and minus signs. So like here's one term and here's another. Okay, and the sign that's in front of each term stays with it. But when we're writing them separately, you're just putting each term over the denominator, again, keeping the sign that's in front of each term. And typically, like, obviously you can't figure out what X is right now, but you can reduce the numbers. So like, what's 4 divided by 2? And then the X is there, it doesn't like disappear, so 4x divided by 2 is 2x. And then what's negative 10 divided by 2? And so this would be an example of me rewriting the quotient as a difference. So applying this rule and simplifying. This is gearing you up to put things into slope-intercept form, which this is an example of. Questions on that? Okay, so then you have 3 more to do. I encourage you to kind of look at it as the announcements play. But once the announcements are over, I'll give you no more than 3 more minutes. And you can use a calculator. You probably should use a calculator. I'm gonna play the announcement now. These are on your paper, so.
Table 3, what did you get as your final answer for number 2?
Okay, I heard -49x over -2, is that correct? Well, it's still a quotient, it's not a sum or difference, so that cannot. You have to rewrite each quotient as a sum or a difference, and this is how you do that. So we'll come back to you with table 3, you can learn from these examples, yeah? I just wanted to. Do you have the answer? No. Okay. Table 4, what's the final answer for this one? Okay, so let's see if that's right or not. What you had to do is apply this rule, so this we proved works. And it's to separate each term in the numerator, make it like its own separate problem, if you will. So like, this is a term. 1 is a term, like there's no variable attached to it. What comes after the 1 is a subtraction sign. That's your start of a new term. Negative 50x is a term. That, you always keep the sign that's in front of each term. So when you rewrite it, applying this rule, it'll look like this, 1/-2 minus 50x over -2. Questions on that? And then the numbers are what we are simplifying. So class is 1 divided by -2, -3. What is it? -0.5 or just -1/2. You can just leave it as -1/2 like that. I mean, I prefer the negative in the numerator, and you'll see why when you start graphing, but it really doesn't make a difference if it's in the denominator. And then is -50x divided by -2, -25x?
Yeah.
It's positive 25x. So almost entirely right, but a negative divided by a negative is a positive. Fix that. So this should be plus 25x because of that negative divided by a negative. But we did simplify the 50/2 to 25, that is right, because they were both negative, so there you go. Question. Okay. Table 3, can you tell me what would have to be the first step in this one? Not in this one. We can't go straight to summary. So when we see this setup, you guys need to recognize that you need to do what? When you see this setup, a number outside parentheses with things being. No, we can't solve. We can't solve because it is not equal to anything. So listen to what I'm saying. Whenever you have a number multiplied by parentheses, and in those parentheses, they're adding or subtracting, what property are you supposed to apply? The distributive property, where you take the outside number and then multiply it by both of the inside numbers. So class was 5 times x. That's 5 times 10. Usually when you see distributing in a problem, you have to do it first. There might be some like workarounds around it, but I cannot separate these terms until it looks something like what we had in the first two. Okay. So then you should have continued working. Table 5, what did you get for this final answer? Come up with something. You guys only had 3 problems to do. I did an example for you. Like nothing is changing. We already did the part that did change for the distributing. The rest should be the same thing we did up here. The only thing that's changing now are the numbers. Table 5, can you tell me what I should have at this step? Okay. Anyone else at that table? Guys, I don't understand what the misconception is. Honestly, we just did 2 problems. We are applying this rule. So, you see how we had two separate terms in the first one? We separated those terms and divided it by the denominator. Here's my first term. Here's my second. Like, do we see that? Do we see where these are in the problem? So can we rewrite? I mean, this one was slightly different because we had to distribute first, but now here's what looks like the past two. Can we rewrite this to look like the other two we already went over? Table 5. Table 5 was my first term. Okay. So we gotta take our first term and divide it by the. Okay, which is. And then what else? Because we have to do it twice. There's two terms in here. What needs to go right here? 50. And what in the middle of them? A plus, because the 50 was positive. Everyone catching on? Because I feel like some of you are disengaged, but then you only care when you're called on. This is a really important field. All right, but this is it. And then we get our final answer, table 6. What's our final answer once we simplify the numbers, simplify the fractions? Perfect. 5/25, if you said 0.2, that also works. But you'll see, like, I don't know if this was familiar to anyone at all. But you'll see that for like slope intercept form, the number in front of the x is easier to graph when it's a fraction versus a decimal. It's easier to go up 1 to the right 5 versus going up 0.2 to the right 1. So for these, we might prefer the fraction. And then, yeah, 50 divided by 25 is 2. Last one, table 7. Do you have a final answer for it? What'd you get? Okay, so let's see if this is right. How many terms do I have in the numerator, class? 2. My first term is negative 1/5 x. That needs to be divided by my denominator. And then what's my other term? And the sign that goes between them is the plus because the 5 is positive. Okay, then we are simplifying, so let's see if negative 1/5 divided by 2 is 10. I'm gonna use my calculator for that because I imagine that a lot of you don't know your fraction rules, and maybe you skipped that one entirely because of it. You will have fractions on your test, but that's okay because you can use a calculator. When you're putting a fraction in a calculator, what do I tell you to use? Parentheses. Otherwise, it can and will read them wrong. So here's me typing it in using parentheses. And I'm dividing it by 2. It'll give you a decimal if it's like not a whole number, right? If you want the fraction, instead, just press this little button right here. And it'll give you the equivalent fraction. So you don't even have to reduce fractions on your own anymore. You could type it in and have it reduce it for you. A lot of handheld calculators have a fraction to decimal button too. Okay. So it's not 10x, it's actually negative 1/10 x. Good attempt if we move the fraction rule. And then 5 divided by 2 is 2.5. Questions, comments, concerns? Not entirely bad on the warm up. In the first hour, it didn't take long. So I'm glad you got it. after the while. So hopefully you're recognizing that these formats look familiar. What do they look like? From middle school?
Oh, I got next week.
It looks like y equals mx plus b. So side note, like slope is probably better as a fraction, because you know, like slope is rise over run. That's easier to go down 1 to the right 10 than going down 0.1. But your y-intercept, that's what you usually have to plot first. Your y-intercept might be better as a decimal. So like, I know it's weird, but slopes can be fractions and are probably better as fractions. For these, the y-intercepts, the single number, are probably better as decimal, but you'll see once you start graphing. We are on lesson 11 today, which is still connecting equations to graphs. That's what we did yesterday. But really, we are looking at the different forms more closely today of linear equations. So you guys just mentioned y equals mx plus b. Slope-intercept form is what it's called. So guess what's really easy to see in slope-intercept form? The slope. And one more thing. Slope-intercept. Your y-intercept. Both are really easy to see when it's in slope-intercept form. So that's why we usually prefer that. That's why you remember it so much from middle school, because they like really drill that in. One form that you might not be familiar with as much from middle school, but we did talk about it yesterday, is our standard form. Do you guys remember what that one looks like? Can anyone tell me? Our standard form. No. That's the one that, when you have a real world problem, like the games costing this much and the rides costing this much and I have a budget of $20. That's the one that when you make a word problem, it's probably gonna be in that form. Does anyone know standard form? Well, it is in your learning part. So your standard form, ax plus by equals c, where a, b, and c are all numbers. That's your other way of a linear equation. This one works more for word problems, but if you're trying to solve that word problem by graphing, you might have to rearrange it into this one. What's alone in slope-intercept form? The y. So if you just isolate the y, then you can create something that you can graph. So we'll look at that a little more closely today. And I record every day, like I'm recording right now. So if you ever want to catch up, relearn something, rewatch something, it's always there. Practice is lesson 11. And you do have a quiz today, so however far we get by, I want to say 10:10. My first hour finished the quiz super fast. So however far we get by 10:10, we're just gonna stop and take the quiz. Know that the lesson is there from last year, so if you want, I don't know, a better description, a longer description, you'll probably find it in this link. But the note sheet's pretty short, so depending on how much you get it, you might get through this pretty quick. All right, but here's the next activity. We have a graph that represents a situation that you've seen in earlier activities, maybe more so on your homework, but an equation that you've seen before. And here's a graph that represents it. You need to describe the relationship between the gallons of water in a tank and the time in minutes. So just use your words. Look at the graph. Describe what's going on. Is it increasing, decreasing, staying the same, and what exactly is increasing, decreasing? You'll describe that on your paper. Then you'll answer where on the graph can we see the 450? Where can we see the -20? And what do these numbers mean in this situation? You do have other people in your group, so feel free to collaborate. We'll go over these answers. Equation, graph. The graph is labeled, we have time on the x-axis. Amount in tank and gallons on the y, so how would you describe it? Okay. I don't know, this is like, I'm not even asking you to calculate anything, just describe something, like how would you describe a dog? What would you say about a dog? All of you. Fur. What else? How would you describe a dog? How would you describe your dog? Okay, so you say things that you can see about it. So table 8, can you say things that you see about this graph? How would you describe this graph? That's what you see about the graph. So let's revise that a little bit. What about in the amount in the tank is happening? It's decreasing, so the amount in the tank is decreasing as what happens? As time increases, that's what we're looking for. There's probably other things you can use to describe it. But yeah, this is a relationship between the gallons of water and the tank. Or the gallons of water and the tank. If one increases, the other one's decreasing. And what specifically is decreasing, you can tell because you can read it. This is decreasing as time goes on. Make sense? Okay. So then table 9, where on the graph can we see the 450? On the y-axis, what do we call it when it touches the y-axis? Y-intercept, good. So here's where it is, the 450. There's no 450 on the x-axis, so there's no way to get confused with it right now. It's on my y-axis, and that's my starting amount of water in the tank. If you look at the equation, it's the number that is not attached to the variable. So our y-intercept is never attached to the variable. Even if we write it out of order, so compare it to y equals mx plus b. They wrote the y-intercept first, when normally you might be used to it coming second. It doesn't matter. The single number, the one that's not attached to the variable, is always your y-intercept. Questions on that? Okay. Table 1, where can we see the -20? Okay. Like, do you see a -20 on the x-axis? So what do you mean by like you can see it on the x-axis? Okay, so I agree, it's definitely not on the y-axis. But in our slope intercept form, we don't expect to see our x-intercept really clearly, so that's not gonna be my x-intercept. So table 2, do we know where the -20 is on the graph? That's what table 1 said, and we already proved that's not correct. Nope, don't see a -20 there at all. So guys, look at the equation maybe for this one. We definitely see a -20 in the equation. Where do you see it? What position is it in? Where the slope goes. So where can you find slope on a graph? What is slope? Rise over run. So where you can see the -20 is in the rise over run, also known as your slope. also known as M, in case you didn't know that. So your slope is always what's in front of the variable. Usually we use X, because whatever we're talking about for that will be on the X axis. They're using a T. T is on the X axis, so it still applies. All right, so we're gonna look at our rise over run on the graph. So rise over run is a fraction, right? So specifically a fraction. If it's written as a whole number, put it over 1. For each additional minute, it is decreasing by 20. So here's my start. If I started at 450 and it's decreasing by 20 each minute, how much is in there after 1 minute? All of you are not. Sorry, one more time.
110.
430. If the slope is -20, that means for every 1 minute, it's decreasing by 20, and you can see that on your graph. So then after 2 minutes, so right here on your graph, how many gallons are in there? No, it's not quite at the 400, it's a little bit above it. 410, because it's decreasing by 20 each time. But do you see that on the graph now? Like it's your rise over your run? Going down 20 for each one? That's where you see it, okay? And in the equation, you see it in front of the variable. That's what they mean in this situation. You could say for every 1 minute, the gallon decreased by 20. And that's a test question. That's probably a few test questions right there. Can you interpret the slope in the situation? Use the fact that slope is rise over run to help you. The axis that rises is my y-axis, that's gallons. The run is my x-axis, that's time. So going down 20 for every 1 minute. Questions on that? Okay. We only have a couple minutes before I have to make you quiz, so let's do the next activity. At least let's start it together. I encourage you to make it probably finish it on your own. But we're gonna look at equations that are in standard form. And we're gonna match them to the correct slope and y-intercept. Because like we said, slope and y-intercept is easy to see in this form, but standard form not so much. So do what you need to do. You could rearrange it. You could rearrange it. It does say you could also use technology, which I'm not really showing you how to graph a line with Desmos, but maybe you can figure it out. It's pretty easy. Make as many matches as you can, and we're actually doing it together, so at least the first two. First, I'll show you with the rearranging technique. So in slope intercept, what is alone? The y. So if I take number 1, that equation, and I start isolating it to get the y alone, then I can see better my slope and my y-intercept. So isolate it. What's farthest from the y right now? Yes, and keep it like, because think about if I want to get the y by itself, to cancel this out, it'd have to become 0. That whole section, not just the -4. So how do I make the -4x become 0? We're gonna add 4x and whatever you do on one side of the equal sign. We're gonna do that to make it 0 plus 3y, so that way we don't have to write that part anymore. Over here, are these like terms? No. So leave it like that. I'm gonna switch the order just because I like the X term to be first, so that's gonna come. Now, to fully isolate the Y, it's opposite of multiplying by 3. And whatever you go on one side. And we get that Y equals 4/3 X, and you can leave slope as a fraction, so long as it's simplified, and this is. And what's 3/3 simplified to? And this is like our warm up, by the way, where you divide from each term. That's what you're hearing about for. So the correct slope. We're now between B and C for number 1. The correct y-intercept makes this answer have to be B. And it's lagging, but 1 goes with B because of that. We could do that for each one, or, spoiler alert, I don't like showing you this because then you don't do this ever. And then you forget how to do it. You could just type this into Desmos and look from the graph yourself. So look at the y-intercept, you could count the slope. Okay. So I encourage you, if you finish early, maybe try it out, try matching the rest, the answers are in the notes posted in Schoology. But we are gonna take the quiz now, so I give you the password. In Schoology, you'll probably wanna close all your tabs.